questions and ask all the presenters the relevant questions that you pose. So the live waste to co-op, as I mentioned, this is the webinar number 2 of the project. The focus of this second webinar is on the production of scrap metals and their valorization into coagulants for wastewater treatment. This project is funded by the European Commission through the LIFE program. And the objective of the series of webinars is to raise awareness of the capabilities of the project, which are targeting a wider pool of stakeholders. We also would like to improve the overall knowledge of the project with a view to responding the market needs, particularly in Europe, but also beyond Europe. The structure of the project of this series of webinars is as follows. We have 3 different topics that we want to touch upon. The first webinar that took place in July 2023 was on brine generation. You can access the webinar on our web channels. And the second webinar today is going to be on scrap metals and production. And this is the topic for today. And then we'll have another third and final webinars towards the end of the year on the use of coagulants. Each webinar includes at least 2 presentations from stakeholders of the project partners, which has experience of the particular specific topic of each of the webinars. And also, we provide an overview of the project for everybody to keep up to date with the purpose of the project and any particular progress. The moderators for the project today is myself, along with my colleagues, Sydney Clare, Eleonora Paisoni, and Elvira Serra. We are here to help and support any need that you have. And please use the chat if you have any questions about the flow of the webinar or the presentations that we'll see in a few minutes. So we have 3 speakers today, one expert from the sector, Mr. José Luis Caravaca García, and then we have 2 project partners, Dr. Feliu Samper-Nájer, and also Ms. Laura Rima Carmena from Global Omnium, which is the coordinator of this project, and IDEMI, which is one of the partners in the project. The agenda for today is going to be as follows. So first is the introduction to the webinar, and we are on that section at the moment. Then I will share the floor with Mr. José Luis Caravaca, who is going to be speaking about the ferrous scrap recycling in Spain. We will pause at that time to ask questions to José Luis. So we'll use the questions that you put in the channel. And then we'll move into the presentation of 2 of the project partners, Feliu and Laura, speaking about relevant project advances. At that point, we'll pause again and we'll have questions and answers, and then we'll close the webinar. So the webinar as a whole is going to be about 1 hour. So just to introduce briefly, José Luis, what we have here is an economist with a strong background in the financial and recycling sectors. He's a senior executive director at José Luis Jareño Sociedad Anónima in Spain. José Luis has been at the forefront of the recycling industry since 2008. And I'm not going to be shy to say that he has been pioneer in sustainability and innovation in the recycling industry. And we are delighted to have him here today with us. Thank you, Luis, for being available. And he will be talking about the ferrous scrap recycling in Spain.
We are a recycling and waste management company with extensive experience in the sector. We have always up to continuous improvement and innovation in our process and management. We have a team of nearly 100 people with experience, knowledge, and specific qualification. We own means and equipment with machinery specialized in valorization process. Don't worry. We have the machinery. We have 3 scrap metal shelves, 2 copa wire mills, scrap baler we have 4, and finally, in this moment we are putting on the shredder, a big one, machinery. And on the other side, we have on fleet of vehicles, container on-site collection, and mobile car presses. This is the big explanation of the José Jareño structure. We offer us customers and suppliers transportation, management, and recovery waste. We offer transportation, management, and recovery waste. We sell ferrous and non-ferrous scrap. Nowadays, we are introducing the waste management of electrical and electronic devices. The discontamination of vehicle of use nowadays is normal here. Management of hazardous waste such as batteries, oils, contaminated packaging, absorbents, so on. You can move the next one, Blanca.
Yes.
Okay. In this moment, I explain more or less the work what we can do here in José Jareño. But for example, today I arrived a bit late because today we have took 2 demolitions. One marble factory in Alicante. We are in Valencia. I don't know if you know where José Jareño is in Valencia, but we work around Spain. And today we have to take 2 business, one in demolition in a factory of marble in Alicante, and the other it's a farm. It was burning 15 days, a farm of hens of eggs, and one is one of our works to do demolition. Okay, we buy scrap, ferrous scrap, and no ferrous scrap on the factories. They produce material for the vehicles, new vehicles. Like here in Valencia is the Ford company, and many of them work to them. And nowadays, Volkswagen company is preparing a big one for batteries. Then we work for all of them to pick up the waste, to the scrap. Okay, that is the more or less what is doing here in Valencia, José Jareño. We on the other side, we buy all of crafts. We have a big deals with around Spain, Ireland, Madrid, south of Spain, north of Spain. We buy scrap around all of Spain to go to the EAF, okay, to sell the non-ferrous scrap. Also, we manage a lot of the copper to around all over Spain. Now I can carry on explaining the. You have moved the page. You can come back to that. Wait a moment. No, one more, please. Okay. Ferrous scrap recycling in Spain. I want to speak we can speak about the tree, and we are going to speak about the forest, the scrap in Spain. Ferrous scrap recycling in Spain. My job I like it. I like to work in scraps. It's mass mastering and spellbinding. Okay, mass mastering. Okay, you have to work. I get up in Madrid. I come back here. Yesterday I eat in Valladolid. I wake up in Salamanca. The day before I was in Cáceres, a small village, to see our suppliers. And then I explain what I do. Sunday evening, normalized, I organize my week schedule. But nevertheless, every single day, the schedule could change. No, it changed. Could no, it changed. No, we have to speak with national customers to normally to buy a scrap. You have to be you have to have the price of the sale after you buy. You don't buy, you don't have the price to sell. We have to speak with the national customer after the national supplier to buy, check the equipment machinery, analyze competitor, solve logistics problems. Every moment. In this moment, I have a phone call with a problem. I am with speaking how here, and after I will solve the problem, and so on. You can change the page, please. What happened? Every day, what happened? Price changing. I came from Madrid this morning. In this trip, I found to ask better prices changing. Supplier looking for solution because they have problem with the machinery. Somebody else has broken the share and is looking for the Avala. That logistics matter. I have many problems in the south of Spain. I have looked for the lorries. Mill restriction. Sometimes the EAF, the mills, they don't vote the scrap because they don't have, they don't sell whatever they want. Another thing is the competitive movements. I don't work with all the EAF in Spain, all the mills in Spain. I work with several, but not all of them. And then the competitors change the prices. I have to follow the market. I have to ask to my customers to ask the better prices. Machinery doesn't work. Every day is broken, the machinery. Every day. Every single day it's broken. Okay, you must looking for the new suppliers because the market is always changing. You need to look for the new suppliers. You can. Okay, thanks, Ching. One problem in the market, in the non-ferrous scrap and ferrous scrap, is the reputation. We don't have a good reputation, but it's changing. One example of this is the LME, the London Metal Exchange. This you can see in Google. You can ask everybody can ask a London Metal Exchange the prices of the metals or scrap, ferrous and non-ferrous scrap, copper and so on. Is intended as a primer for those who want to develop their understanding of how commodities and metal market work. It's very interesting, the LME. That is for our reputation, okay? And the other side, we have here to speak about type of steel scrap. No, not too much complicated. The type of the steel scrap. All steel scrap, new steel scrap from factories to produce cars and so on. Heavy scrap steel, shredded steel scrap, steel savings. Here the type of steel scrap is easy. The problem is the person who manages the scrap. Okay, the problem is the customer and supplier, the person, not the scrap. Okay. Nowadays we are speaking about the figures of the steel in Spain. The steel production in Spain is stable or decreasing. Nowadays, is more usually the work with the steel usually is in countries as Asia or more or less Asia, better than Europe. The steel production in Spain is stable or decreasing because the production is cyclic. If we compare the production of 2013 and 2021, they are similar. However, between 2013 and 2022, there is a decrease of 20%. Carry on. Okay. Here in the TSH table, worldwide production, Spanish steel production between 2013 and 2022, it had decreased. After we can see the map of Spain, we can see the mill with working now. The worldwide figures are changing. They are growing. In the years, the growth has been of 12%. The rise appears in Asian countries such as India, Malaysia, Indonesia, and so on. Okay, that is the change from Europe to Asia, the production. Okay, as other markets, China is the head of the national the market. China is the move it. On the other hand, the Spanish market for recycling had experienced a significant shift in production of electric arc furnace. Electric arc furnace was introduced in Spain more or less 60 years ago. Nowadays, the technology is working properly. The number of mills in Spain is decreasing. In 2018, there were 21 operational electric furnaces. Nowadays, only 15. If you check the two maps from 18 to 23, we can see that in the middle of the Spain disappeared the mills. Only one in Madrid. 5 years ago was 2. Maybe in 3 years in Madrid disappeared the mills. Always looking for both markets, national and international market. You cannot sell from Madrid to the international market. Okay, carry on. Okay, we have a good luck, Blanca, because today we are putting in Avilés, Arcelor is putting the first stone to build a new EAF. Because in Spain we have only 2 blast furnaces. They belong to Arcelor. Although they are restructuring, Arcelor is building a new EAF, and today they put the first stone. We are the owner of the company and so on there. The mayor of the Avilés and for the picture, using green hydrogen to work. Okay, and then it will shape the future landscape is changing. Okay, the blast furnace is going to Asia, and in Europe always we are using the EAF, electric arc furnace. That is very important for the environment. Spain has a negative balance in scrap. We need to import scrap by bulk ships. Okay, in Spain we don't have enough scrap. We have to to buy scrap north of Europe or USA, more or less, or South America. Okay, we buy the bulk ships. Probably Spanish scrap price have an interrelationship with Turkey. Okay, Spain is a small country to produce the steel. Spain depends the Turkish price. Turkey has built the biggest cluster to produce rebar in the world. Furthermore, this is also a relationship between scrap and come back. The prices of the scrap it's the same price of the rebar prices. Change is always going in the same way. Turkey have maybe 100 mills or EAF in between the Europe part to the Asian part. The Hatay province. Hatay province is close to Syria, and they produce the prices. We're speaking about the prices of the scrap is always speaking about the Hatay prices. The relationship. The main question is what will move the Turkish scrap price? What put in Turkish scrap price? Because the scrap price nowadays, maybe China is who manage the prices of Turkey. Okay. I think
Okay.
Okay.
Yes. No, thank you very much, Jose Luis, for your presentation. Yes, apologies to everybody in the webinar that we are on a little bit late. We had a few technical problems at the start. I'm going to invite my colleague Elvira now to follow with the questions and answers. Please, Elvira.
Thank you, Blanca. So I'm going to start with a question that we have from one of the people attending the webinar. This question is from Nayara Fonseca, and she would like to know why do you think the number of EAF plants have reduced in Spain? Do you have any idea of what that has happened?
What happened? Because it's more cheaper to produce out of Spain.
Okay.
It's more cheaper to produce in Turkey. The electric prices and the personal cost and so on. It's normal. And also Asia is cheaper than Turkey, I think, in this moment.
Okay, cool. So maybe we have time.
Sorry, but the quality here is better, but they don't pay it. Okay, that is the problem.
Cool, perfect. So then we have another question, and it's more like just for us to know. So because you are working in, like the recycling business, we were wondering if you were the owner of 1,000 tons of ferrous scrap metal right now in Spain, what would you do? Would you try to keep it for a while and see if the price increases, or you will sell it right now? How do you see the market, and what do you think that is the best option?
We have to check it. The relation between Spain and Turkish prices now is very close, too close. And then one point to sell, and the other point is that the price of the scrap is expensive in this moment. I will say as fast as I can.
Okay, cool. That's a good answer. So we know what we have to do in the case that we have these 1,000 tons of ferrous scraps. So another question is about the prices also of the scrap metals. what are the main factors that are affecting the prices of these scrap metals? And if you have seen this, that these factors have changed over the last few years?
Look, it changed, but the year of 2020, we have a big problem in all the world, and the prices, I have never seen the prices of this. It was close to 500 euros per ton. It normally is 300 euros per ton. This price, it was more expensive than the 28. It was also a very the prices in Spain was a good situation until 208. But 2020 was the prices is well, okay. Also the Ukrainian war. Okay.
Okay, cool. I don't know, do we have time for another question, or we should?
No,
we have
unfortunately
time.
not. Yes, but if José Luis can stay till the end, maybe there are going to be other questions where you can also help us identify the best answers for that. So thank you very much, José Luis, for your presentation. It has been really interesting and very useful for this project. Our next presenter is going to be Dr. Feliu Sampere. He is a chemical engineer with very prestigious academic credentials and international experience, and also expertise in waste treatment and biogas purification. He has joined Global Omnium in 2019, and since then he has been engaged and involved in many interesting projects, which has led to this project today, the Live Waste to Coac. He's leading the technical coordination of the project at Global Omnium, and assists the project coordinator, Tatiana Montoya, in this project. So now Feliu is going to provide us an overview of the project and latest advances. Thank you, Feliu. The floor is yours.
Thank you, Blanca. Hello, everyone. Do you see my presentation? Okay.
Not yet. Not yet. Now we see it. Yeah.
Now? Okay,
Yeah.
perfect. Okay, this is the content. I will start with the context, the concept of the waste to coke solution, and overview of current status, and also the afterlife transferability. Okay, the context is the problem to solve. We have a high worldwide coagulant consumption, which is applied mostly in urban wastewater treatment plants, but also for industrial wastewater treatment. Okay, there is a continuous price increase, and normally we have to outsource this, which indeed, for example, in the UK, the coagulants have been defined as critical goods, right, for industry. And as said, if coagulants are expected, the consumption to keep increasing, also to more stringent regulation on final effluent values in wastewater treatment plants. Also, there are a huge brine disposal from desalination plants, from 142 million per cubic meters per day, also in desalination, but all other industries also produce brines. And these brines, 80% of their production is released below 10 kilometers from saline water bodies, but 50% of this production is also away from saline water bodies, which difficults its handling, mainly in China, USA, and Spain. And the release of these brines, regardless where they are released, pose an environmental impact in the receiving bodies. So our concept of the project is based on electrolysis with the valorization of brines, both wastes, brines and metal wastes, into coagulants. Okay, this was carried out by IDEME and Global Omnium since 2015. from laboratory reactors to pilot scale reactors of 100 liters, which was the previous project, using, as mentioned, an electrolytical technology to produce the iron and aluminum-based coagulants. Just to highlight what the electrolysis is about, is to apply a continuous electrical current to two metal electrodes to cause a non-spontaneous chemical change. If we use as an anode a sacrificial electrode, steel or aluminum, we are producing the substitute of iron-based coagulants or aluminum-based coagulants like PAC. Why we are using brines? We are using brines because the higher conductivity of these solutions allows to apply lower voltages. So that implies a lower electrical consumption in producing these coagulants. And then this led us to the current project with a total amount of 1.5 million euros co-financed by the European Commission under the LIFE program. The project finishes after an extended time requested and approved until September next year. And we have IDIME, Jovial as partner for industrial wastewater treatment plant, ILE, who is organizing this webinar, Aquafin, and water utility in Belgium, and Global Omnium, also a water utility. Summarizing the project, the packages that we have in the project is the obtention of administrative permits, the design and construction of the prototype, which was led by IDIME, the optimization of the prototype operation to produce the coagulants, and their application in wastewater treatment, which is an action that just finished. And then their validation of these coagulants into urban wastewater treatment plants in Spain and Belgium, and also in an industrial wastewater treatment plant in Jovial in Spain. ILE is leading the market access and exploitation of results, and also we have as an action the environmental and socioeconomical studies of the solution, the dissemination activities, and finally the monitoring the impact of the project, and of course the coordination of it. Today, nowadays, we are in action B5, the transferability of the industrial plant in Jovial. Here you can see a picture of the HMI of the plant, where it's schematics of the process, a receiving tank for the brines, the electrolytic reactors, which we see here in the picture on the right side, and then a receiving tank of the coagulants from where they are dosed to the wastewater, industrial or urban wastewater. We have 3 demo sites, 2 urban wastewater treatment plants with different brine characteristics and from different origins, and also an industrial wastewater treatment plant to transfer the results to a totally different type of wastewater, and also dealing with a different amount and conductivity of the brines produced, which are in the same factory. As a result, we checked the purity of the scrap metals used as electrodes, and they were compared to commercial electrodes. And what we saw is that the purity of these metals was very high, with, in case of aluminum, about 96% aluminum content, and in the case of iron, almost 100% content. And the production of the coagulants, what I would like to highlight is that on the left, we have the results of previous R&D projects. Based on the concentration of coagulants, we reached 200 milligrams of aluminum per liter, and now in this project, at different electrolysis time, we increase them to 1 gram per liter, which increases the valorization of brines. Let's say for the same amount of brine, we can produce more coagulant. And this is done using a lower energy consumption per kilogram of metal compare also to previous projects where we have values as high as 60 kilowatt-hour per kilogram of aluminum. And this is a result of the high conductivity of brines that we are treating in this project. And then we also evaluated the toxicity of these coagulants, which we have in this slide with respirometry tests, both on autotrophic bacteria responsible of nitrification, but also on heterotrophic bacteria. What we made trials with activated sludge of respirometry to evaluate the oxygen consumption, and also activated sludge with the alternative coagulants, which we are producing. And what we saw is that there is indeed a boosting of the respirometry in both type of bacteria. This is not the objective to boost respirometry, but to check if there was any inhibition on the biological process, which clearly these results demonstrate that they are safe to be applied in biological reactors as those that will be used in urban wastewater treatment plants. And then after this, looking forward towards after the end of the project, we are looking for transferability to test different type of brines to be able to process them initially maybe at laboratory scale and afterwards in the demo plant, and also to apply our coagulants to other wastewater different type of wastewater. So we are happy to assist you if you want to reach us. So for that, you can contact either ILE or ourselves as coordinators in this email or visiting the webpage. So just to finalize the conclusions, the brines and metal wastes are correctly valorized. The electrolysis concept has been correctly scaled up from previous projects. And these coagulants are safe to be applied on activated sludge reactors, and we look for networking with other stakeholders. So thank you for your attention, and if you have any questions, I'll be happy to answer them.
Okay, so thank you very much, Feliu. We are going to move now to our last speaker, who is Laura. Laura is also a chemical engineer, also based in Valencia, with a master's from Cranfield University in the UK. She has a track record working in research and development and also project management at international companies, and she joined IDIME in 2017. Since then, she has contributed to many national and international projects, and she has transferred, or she's transferred at the moment, her knowledge and experience to MSc students at the Polytechnic University of Valencia, where she's also undertaking her doctoral studies. So I'm sure that you're making a great role model for them, Laura. And as regards to the project Live Waste to Coag, she works with IDIME in the design, commissioning, and operation of the electrolytic pilot systems. So without further ado, Laura, the floor is yours.
Can you hear me now?
Yes.
Okay. I will try to share my screen. Please let me know if it's working. Do you see the presentation?
Yes, it's loading now.
Okay, thank you. Thank you, Blanca, for the introduction. In this presentation, we will first review the technical concepts of our project. Then we are going to see the key innovations of our LIVE solution. Then we will explain the metal scrap selection for our system and see some pictures of the coagulants that we have generated in the pilot plant. Okay, as you know, this is a multi-sector approach because all the different streams of the project come or belong to very different industries. As you know, the main objective of the project is to generate high-quality coagulants, which are going to be used in the wastewater treatment plants, both from industrial plants and the wastewater treatment plants. For that, we need to control the key parameters of the electrolytic system, and we have to be very careful with the inputs of this plant. On the one hand, we have the brines, which are the high conductivity liquids that come from desalination plants and from industrial plants. And on the other hand, we have the scrap metals that come from the metal industry. The focus of today's webinar is going to be the selection of these scrap metals, okay? A quick review: the coagulation is a wastewater treatment in which we destabilize the polluting particles from water so they can settle and they can be removed from water. The conventional coagulation does this by means of the addition of reagents like chemicals such as the iron and the aluminum salts. And in the electrocoagulation, we are doing the same, but by the use of the electric current. So we can generate the active species directly, okay, in situ. But what are the main difference of the electrocoagulation and the electrolytic system that we are using in this live plant? In here, we are going to see the comparison with of the electrocoagulation and our system, okay? First, the objective of the electrocoagulation is normally the wastewater treatment, while in our case, we want to produce coagulant and valorize the wastes, okay? Both the metal scraps and the brines. As for the electrodes, in the electrocoagulation, normally we use commercial electrodes, while in the electrolytic systems of the lab, we are looking to valorize the metal scraps, which normally are cheaper, and it's good for the environment because you are valorizing these wastes. On the other hand, the electrolyte in the electrocoagulation is normally the wastewater that you want to treat. And in our case, we use the brines, which are high conductivity liquids, which means that we use a lower power consumption, and we prevent them from being released to the environment, which is harmful for the ecosystem because of the high salinity of these liquids. Besides, regarding the versatility, the electrocoagulation is normally a standard process, while in the live waste to coag, we have to cope with a wide range of qualities, both from the metal scraps and the brines, and also we have to be able to deliver a wider range of qualities of the coagulant, depending on the necessities of the end users. Okay, the input and the final requirements are usually not the same. As the similarities of both processes, we have that they are both easy to operate because they can be controlled by the power source. So with the power source, you can control the reaction and you can generate the amount of coagulants that you want in situ. None of them uses reagents in terms of acids or bases, or the coagulants, of course, which means that we produce less sludge, which is good. Okay. As the main advantages of our process, we have first that we generate commercial coagulants, that they can be commercialized or used in situ in your plant. We are valorizing wastes, the metal scraps and the brines, and we have a low power consumption because of the high conductivity of these brines. As for the scrap metals, we have said that this is obviously not a direct operation. For the metal selection, we had that we will talk about the quality in the next slide. Then about the price, we know that no one can guarantee a stable price nowadays, but at least we are looking for a lower price than the commercial electrodes. Then as for the shape, the scrap market has a wide array of shapes going from profiles, coils, corners. And in our case, we are limited by the reactor configuration because we are using a filter press configuration. And that means that we have to use the flat sheets, as we can see at the bottom right of the slide. Okay, as for the thickness, dimensions, and quantity, these are physical specifications that depend on the quantity of the coagulants produced. As for the thickness, the more weight, the more metal that we can dissolve. So we have to make sure that the thickness is enough to withstand all the project duration for the coagulants that we want to produce. For the dimensions and quantity, they are defined by the current density that we want to apply in our process. So we will have to shape this as well and define this as well. And finally, we had to look for a good availability. Of course, the metals have to be ready for when we wanted to buy them in the process. Last but not least, we had to seek and select the supplier that met all these requirements, which is not easy. Okay. Then the quality requirements, as we have said, not everything is welcome in this plant. We are looking for the highest purity of the metals, or else we can contaminate water, we can inhibit the biological treatment, or obtain a low quality of the coagulants because of the impurities that the metals may contain. Okay, for example, in the case of the ion electrodes, the use of the stainless steel or galvanized steel is directly not allowed because they contain a high amount of chromium or zinc in this case. For the aluminum electrodes, we are looking for the series 1000, 5000, and 6000 because they contain a low amount of the alloying elements, which are, in this case, for example, the manganese, the zinc, and copper. So we are looking for both of them a high purity. In the project, what we did was first buy some scrap metals and compare this quality to the commercial electrodes. We took some samples and compared their purity using the spark emission spectroscopy, giving great level of purity for the iron, the 99.5, and the aluminum 96.8, which was really good. But besides this, we did some validation tests in the lab using the maximum current density just to check that the dissolved impurities were within the limits of discharge. Okay, so everything was safe for the biological treatment and the discharge parameters. As these results were good, we considered that the electrodes were suitable to produce the coagulants. We bought all of them, and after that, we proceeded with the installation of the electrodes in our electrolytic system. We bought them, then we had to take a lot of times the measurements of the electrodes. As you see here in the presentation, we used a wooden electrode and to check that they fit inside the reactor. Regarding the connections, nothing is left to chance. The section of the connections have to be carefully calculated considering the different conductivities of the iron, the aluminum, and the copper wire to make sure they could resist the current that was going to flow through them and so make everything safe. Then, I don't know if in the picture it can be seen that all the anodes are connected to one side of the plant, to this bus bar, and all the cathodes are connected to the other side of the plant, just for the sake of safety, so the operators can be safe as well. Finally, we are showing you some pictures of the coagulants. In the left one is the iron coagulant, and in the right picture is the aluminum coagulant that we have produced in the plant. And of course, we have here the VIP visitor that came once to the plant, the dragonfly. And as the conclusions, we have overviewed the process. We have seen the advantages of the live waste-to-crowd solution. Then the scrap metals, we could valorize the scrap metals into coagulants in a pilot scale and generate them with good results. And finally, we would like to emphasize that there is no magic in here. Everything has been calculated, and the design of the plant has been based on the coagulants that we aim to produce. This was based also on the operational parameters, and depending on the validation results that we checked the the efficiency of the coagulants. Then we had to optimize the production again. So everything is an iteration, which means that there is a lot of work that has been done, but there is still a lot of work that needs to be done. So thank you for listening. I hope the content was interesting and useful. I don't know if you have any questions. Okay. I will stop sharing the screen.
Thank you very much, Laura. Thank you very much for your presentation. Yeah, we have a few questions in the chat. Nayara was asking for you in this case, if you have a country in mind where to obtain the scrap metals when the technology is implemented.
If we, sorry?
If you have a country in mind where you can get the scrap metals for the waste to coag solution, also Laura, you can chip in if you want.
A country in mind. Ideally, it would be best to get the metals locally, because this technology aims to be self-sufficient and to be implemented in local areas or industrial parks, so you can get both locally scrap metals and brines, and in the same in nearby wastewater treatment plants, either urban or industrial. Yeah.
Yeah, maybe this can also reduce the impact of the technology.
Yes, exactly.
And Laura, we have a question about electrocoagulation. Joy is asking, so he's working for a firm that is proposing to use electrocoagulation to remove PFAS. Have you ever worked with electrocoagulation for drinking water treatment?
For the drinking water treatment, not yet, but it has been proved to remove the organic carbon, or everything that is suspended solids and the contamination associated to the suspended solids can be studied. So I think it could be some good tests to do, and of course it can be tried, and I think it may work. We will have to change some parameters, but it could work. We haven't tried it in this process because we are producing the coagulants. We are not treating wastewater, but of course it's a technology that may work.
Thank you. And last question for Feliu. Do you think that the best result in respirometry can be an argument to replace then the conventional coagulant with the live waste to coagulants?
Well, indeed, that was not the purpose of the project, and it's a surprise, but we also have to take them carefully, and we will look at them when testing the coagulants in the treating real wastewater, and not with only respirometry assays or jar tests. But indeed, it is a parameter that we are going to follow up. Yes. And it would be a very good argument, indeed, if it's linked to a high removal of pollutants, because if you are going to remove the same consuming more oxygen, then that will not be that positive.
Okay, thank you. Blanca, over to you.
Thank you, Eleonora. Thank you, Laura. Thank you, Feliu. And thank you, Jose Luis. I think he has left already. He is busy. Maybe he's going to be sleeping tonight somewhere else again. Thank you all for your presentations. They have been really interesting, and we have learned a lot today. I hope everybody here in this second webinar agrees with me. On the screen, you can see links to be able to follow us through social media and also email. Please engage to ask any questions if you would like to learn more about the project, and for you to be able to see what is the progress. And please keep an eye also at the social media. We will start promoting our final third webinar of this series just after the summer. Thank you very much all. And with this, we close this second webinar. Thank you. Have a good rest of the day.